Okay, so you want to learn how to model stuff like Dr. Learf. I know we've all seen the animations. Unfortunately, you're not going to be able to, but you can kind of get there using these simple steps. So he, in his simulations, he uses CM1 to simulate clouds. Unfortunately, if you go to the website, it's all just the data. It's not compiled code. The link that'll be in the description of this video will be the compiled code. Boom, this is it right here. I'll get a direct link so you can just download it straight away. Okay, there it is. Hey, look at that. Yay, you can download it and it'll take like 5 seconds, whatever, blah, blah, blah. So now you have your zip file right here. If you don't have zip, boom, I'll leave a link in the description. Go download WinRAR, boom, click it, run it, save it, install it. You're ready to go. You'll be able to open the zip file, crack open your zip file, take the run, or in this instance, it's just called run. Throw it on your desktop. Could not be easier. God damn it. Well, now that you're done with that, you're going to need to edit some of the files that are in here to be able to do stuff later on. With this, we use Notepad++. I'll leave a link in the description for the latest version, which is just through the installer. Boom, there it is. That'll leave a direct link on that. And then also what you're going to use to show what you modeled is you're going to be using Visit. Visit is just this. I'll leave a direct link since I don't think you can run CM1 on a Mac OS, so you're just gonna have to run it on Windows 10. Direct link will be in the description. Just check down there so you download it. Download Visit. This is a bit of a cut-in. Turns out I didn't actually install Visit, so we're just gonna install it now so I can show you how you install it. Just ignore this. This is actually a really trusted program. I don't know why that popped up. I'm actually kind of surprised that popped up because that's actually like a really trusted program, but you know, whatever. Alright, so we're just gonna go through. Yeah, it's just me. Yeah, sure, install in that folder. Yeah, looks good to me. Yep, looks good. Yep, definitely looking good. Don't care about these. Alright, visit is completed. Just close out of that. We don't need to open it right now. Alright, so now you got CM1, you got visit, you got Notepad++, and you're able to open this and you have this on your desktop. Now, this in itself won't really work. You need a sounding for it to model. And what we use for that is we use Sharpie. Sharpie is a program that just models soundings, and you'll be able to output text documents that CM1 will be able to read. And you're gonna go. I recommend taking the latest version. However, Sharpie 1.4 is currently broken, so we're not gonna do that. We're just gonna do the pre-release version. Boom, you have this guy. I haven't actually downloaded it yet, so we'll just download it and throw it on our desktop. Alright, so just to inventory, we have Visit, we have the CM1 model precompiled right here, and we have Sharpie. So now we are going to get a sounding from Sharpie. So we're just going to crack it open. You can use really anything you want. You can choose any sounding you want. You just have to be able to find it in the archives of Sharpie. Eventually it'll open. If you're using older versions, it should pop up with something that says, oh, update to the newer version. Yep, see newer version. I don't recommend this because that version is broken, but if later on this video will probably become obsolete, they'll update it and they'll have a version that actually works. But, you know, we can work with this for now. It's fine. Don't know why that happened. So we're just going to go find, let's just go back to, let's choose an April 27th sounding. How about that? April 27th. There it is. So I'll have it and I'll set here to load for a bit. Alright, now that that's loaded, we'll just zoom in on the warm sector. Let's do Birmingham. So you just go over here, select your sounding source, select your date, select what time frame you're going to. So 23Z, so 5 p.m. at Birmingham. Let's see what this air was like around 5 p.m. at Birmingham. So obviously very tornado conducive sounding right here. I mean, I don't see any really flaws except for it's a little interfered with, but that's okay. So what you're gonna do is you're gonna click on profiles, click on interpolate focused profile. So click on that and wait a second. And that sounding will slightly edit itself, but that's good. That's fine, you don't have to worry about that. You're gonna click save text. So I'll just save it to my desk, just April 27. Okay, there we go. So now you have this text. Now this text, if you scroll through it, if you see values like this, you want to remove it. So you don't want to change it. So what I just do is I just delete it back, 79, boom, boom. You can't run soundings on CM1 that has the negative 99999 stuff in them. So you gotta change it. That's the reason why you click that interpolate profile thing, because it'll get rid of most of them in the sounding. And also what you gotta do is you have to remove that percent and percent thing at the end, because it just doesn't work then. So you're gonna click save. Now I did some really stupid there. I recommend opening this in Notepad++, that program we just installed. So you're gonna open it. Yeah, okay, everything in here looks fine. There's nothing that's wrong here. So we're gonna click save as, we're gonna click on file, we're gonna click save as, we're gonna save to desktop. Now you'll see how it says normal text file. You wanna save this as nothing. So you're gonna scroll up, you're gonna click all types, so star.star. And then you're just gonna click, and you're gonna type in as input, input sounding. Boom. Save to desktop. So there you go. Now this is your input sounding. This is what you're going to put into CM1. So if we open up CM1, we're just going to put this son of a gun right here. Okay, before you click on CM1 to start modeling all this, what you should do in the first place is right click namelist input and you should crack it open. So this is your namelist input file. Now don't get scared. This is just a bunch of really easily understood programming language. And if you're really confused by everything, there's a link I'll leave in the description where you can look at user's guide for namelist.input file located in the run directory. This is just all of this just put into words so you can understand every single thing. So if I really wanted to figure out oh, I moist, so let's go search find I moist. Boom, there you go. If you really want to change that variable, you can. So that's pretty much how you find stuff from here if you want to try to change it on here. Now the first thing you got to do when you open this nameless file is if you're using Sharpie soundings, you need to change this variable on line 74 right here, ISND. You're going to change this from 5 to 17. You're going to save that. That'll save you so much heartache. That will allow the sounding to be able to be run if it's a Sharpie sounding. Now there's a couple of other things that are easily understood on here. This right here, TI max, this will be how long your simulation will generate out to. So it'll generate out to this amount of time. I don't really recommend simming it all the way to the end, because not all the time you'll have a cell that's still in the domain. It'll move out of the domain or die or become a line or whatever. This is how much time steps go into it. So if you're counting down, this is each time step. So it'll go from 10,800 to 10,500. Really simple. Here's another really important variable that needs to get down is umove and ymove. This will be, since storms in real life and in this simulation will move, the domain has to move with the supercell. Now, not always will it be correct. There's a couple of ways you can calculate it on your own. Currently, the guy who actually compiled this, Anthony, he is trying to develop a system that'll have the storms move directly with the domain, so you don't have to edit this, it'll just edit itself. But I always like to set a good basis. I just go 5.0 and then just 0. This is always a good way to set it. So we'll just save that. So every time you change something, make sure you save it so it'll be able to be run by CM1. One of the most important variables here that you'll be able to change, I don't really recommend changing anything else. The only thing I would add is if you go down here to outputs, I'd recommend changing output SVS to 1. So I'll change that to 1, save. And then the other one is if you go down here, output vort. So that just vorticity. And I believe the SVS one is relating to something to do with like surface vorticity. It's hard to understand. I'll be able to show you it in the model. But it helps you show TLVs, which is something I'll talk about later. So back on track to what I was talking about, parameters 4, 5, and 6. These are really easy to understand, and they're very important. So what these deal with is the resolution output of the model. So if you look over here, it just talks about how what these represent is the grid spacing of the model. So inside the model, it has a certain number of grid points, and all those grid points are simulating something about the storm or the air around the storm. So if we look at it, stretching is on. What stretching is it's a gradient almost of how big and how small the grid spacings can be. So with DX outer being on 2000, the air around the storm will more than likely be simulated as 2000 meter grid spacings, while inside the storm they'll be simulated as 1000 meter grid spacings. This is quite large. You can go down, down to, you know, like let's say 500 or 400 or 100, which I don't really recommend unless you have a supercomputer, but let's say 500. Now one of the things that you can get wrong here really easily is you can make your grid spacings have too much of a gradient. So what I recommend is I recommend having it at least close to each other. So I guess for my models, I want to do, we'll do 500 meter simulations for the first one. So make sure that as well, you got to set this along your x-axis, and you also have to set this along your y-axis. So here we're going to go to 500, 500. So now we're going to edit these variables. This is the length and this is the length and this is the width of your domain. So here's the total length of the domain. So the total length of our domain is 120,000 meters, or about 120 kilometers. So now I could simulate an entire supercell 120 kilometers. That's cool, but it's a little big for me. We'll go down to 100 just so we can make it a little faster. Make my computer run a little quicker here. So we're going to save that. So we'll go down here to the Z parameter here. So what this is this is just the height of the domain right here. So it's X, Y, and Z axis. The Z is up and down. And here we have it set to 20,000 meters. That's fine. You know, you want to be able to see the top of the storm. You also want to be able to see the vorticity that's up above the tornado or the storm or wherever you're simulating. You can change some of the variables here to mess with the grid spacing. I never really touched this, and I won't touch it here, so we'll just leave it as it is. Alright, so now that you edited these to whatever you want and how you want to change the resolution and how you want to see the storm, you're going to need to run CM1, and that'll generate the output that'll be used in Visit. So the way I recommend running is you can go and just run CM1. That's fine. However, if you mess up one of the variables, you won't be able to see what you did wrong, because when you open CM1, it'll crash. I think let's see if it'll crash, because if it opens, it'll just crash if I edited one of the variables wrong. We'll see. Boom. See how it closes? So what you're going to need to do is you can click run. You're going to type in, I guess in this instance, we'll just type it in, PowerShell. Boom. There's your PowerShell. So what this is this will allow you to see what you did wrong with the program. So what you're going to want to do is you want to navigate to the folder. This is how you do it the fastest way. You go to whatever folder is holding CM1. In this instance, it's on my desktop in a folder named run. So you're going to click up here. You're going to copy this. So C:/users DASO desktop run. You're going to copy this. You're going to go to PowerShell. You're going to type in CD space apostrophe. You're going to right click and it'll paste that into there. You're going to end it with apostrophe. Boom, you're inside the folder. So now all you need to do is type ./cm1.exe and it'll run. Now I think I set the variables wrong over here, so we're going to do some troubleshooting right here. Aha, I did. So if we look through here, don't be intimidated by all this programming language. This is fine. So with the resolution settings and how big the domain space is, what's asking me is needed for these settings. So the settings I put in, so if we go back down, you know, the ones I set, the NX value should be 200. Now this will be applied to also the NY variable. That's what I meant to say. So 200. Boom, save. Now if I run it again, it will run the program just fine. Alright, so here's a problem you can run into sometimes where your sounding actually needs to be bigger in your grid. I know it's kind of weird like that. The Zmax of sounding is less than Zmax of grid. Now this has to deal with the sounding that you chose. So let's say my April 27th sounding, okay, it wasn't the best one I've ever used in my whole life. So, well, you're just gonna have to go get a new one. So, I think I already have one saved on my desktop. Ah, here. This is some crazy OP sounding one of my friends made. So we're just gonna go through the same process. Looks good. Everything's removed. So we're just gonna save as to desktop as input sounding. All files, desktop. Boom. Now, whatever you do with that sounding is whatever you do with it. In this instance, I'm just going to delete it because I don't need it anymore. We're going to throw this in here, and then we're going to open PowerShell. We're going to run it again. And it should start making the space. Okay, so now what it's doing now is it's writing data to the file of the sounding that we made. So now it's interpreting the sounding and it's going along, it's making everything. Now, the thing I recommend the most is if you're doing really big resolutions or you're doing really long times, you're going to want a lot of hard drive space. I mean, we're talking up to like 500 gigs if you want to do, 50 meter soundings. I've never done them before, but if you want to do it, you can, but you're going to need a lot. So if you see in here, all where it's writing all this data to is this file right now, CM1 out.nc. This is what we'll actually open with Vapor, or with Visit. Now you can open Visit in this process. It's fine. You can do it. So what we're gonna do now is we're gonna open Visit and we're gonna set Visit up for some parameters and stuff you can use to help view. So I have it installed under my users, under my name, under my profile name. Visit.3.1. I'm gonna scroll down here. Visit.exe. I recommend just send to desktop as a shortcut so you can easily open it. So now we're gonna open Visit. So obviously when you open Visit, it's gonna want to connect to a server. It's fine. You can allow it. It's fine. It's not that big of a deal. You can allow it. It's okay. Yeah. It's fine. One of the first things you have to do is you have to click Open. So what you're going to do is you're going to navigate to wherever you have your run file. Let's see if I can find it. So this is I have on my desktop. So boom, here it is. And you're going to find this file and you're going to want to open it and Visit. So if we can bring that back. So you like use this, go up, go down. Click on run, click here. So you're going to click cm1 out.nc. You're going to click OK. And now load as a source. It's fine. You can load it as serial. It's okay. And now it is open. So what we want to do to interpret this is a couple of different things. One of the easiest ones is you click add, you go to pseudo color, and you click DBZ. So now we have pseudo color. So you can open it, close it, make it subset. We don't care about that right now though. So what you want to do is you want to keep this, you want to click this open, you want to click on operators, you want to click on slice, and you want to click slice. So now this is added as a slice. So you want to click on it, click to change the angle of it to the z-axis, and then you want to hit apply, and then you just X out of it, and then when you're ready to go you hit draw. So now what it'll do is it'll output it to here. So I haven't stepped forward, so let's step forward. So you can see the storm kind of developing. Obviously it's kind of really small in this very big space I have right here. Let's refresh it and see if oh look, there's a new scan. So you can scroll forward, boom. Now obviously every environment is different, there's different ones. I'm going to show you a couple of different variables you can add that'll make it so much easier. So one of the variables that you can add to make this so much cooler is vector plots. So what we're going to do is we're going to go to controls, we're going to go to expressions, we're going to click on expressions. You see I already have a couple in here. This one doesn't work currently, so there's a different way to simulate clouds. I haven't figured it out yet, but if you were to simulate clouds, you just you'd insert this into there, you'd make it a scalar, and you just apply it. You'd be able to model clouds, like it would show up. If I go to pseudo color, there's cloud. So in this instance, what we want is we want vectors. We want a surface map so we can see which way the winds are blowing. So we're going to click vector mesh variable. We're going to paste this line in there. I know it's hard to see. That's fine. So we'll just name it vector mesh. Okay. We're going to hit apply. And now we're going to close out of it. So what we're going to do is we're going to just click add. We're going to click vector. We're going to click vector mesh. So here's your vector mesh. All you want to do is you just want to go in there. Want to check slice, slice, and you also want to set this one to Z axis. Also, if you're having a problem where one of these operators that you add is showing up for the top and the bottom, all you have to do is click this button off, and that'll save you so much heartache between these being constantly for both of them. So now that you have this here, you just draw it, and now you have vectors. Now I know you want to have add more vectors because there isn't really anything there to work with. So we'll just click on this and we'll change the data. So you want to have this uniformly set throughout the mesh. So you want to have it in every single part of the domain. So there it is on every single part of the domain. You want to change the number. So in this instance, we'll go to 4,000. 4,000 is pretty good. So there you go. Now you can see all the arrows. You can see which way the wind is blowing. And in this instance, it's blowing towards the thunderstorm. It doesn't appear to be any rotation yet with the thunderstorm, but that's fine. One of the other things you can do is you can add base velocity. So we'll go to pseudo color again. And we're going to do, in this instance, we're going to do vertical velocity. So winds that are blowing up and down. If you color this right now, let's see, that's because I didn't add it as a slice. That's one of the things that'll get you. So we had slice, surface, change it to Z-axis, apply, boom. Now you can draw it. So click draw. And this is a really crappy view, so we're going to change it. The way you change the color table is you click on default and you can change it to whatever you want. So I guess let's use turbo. That's not that good of a variable. Let's do another one. Is there any sharp difference maybe? Now whatever, it gets the idea. You can see there's obviously winds that are blowing in and out and away. And there might be some anticyclonic we form in there. You can change the variables here to something else. So if we click use original data, maximum, minimum, you can set the top and the bottom velocities to set distance. So I like doing -150 and +150. So now these will pretty much disappear. It'll go lighter, but if you have something that has really substantial velocity, it'll stick out more. So you'll be able to see where intense couplets are if you have storms that form really, really well inside of the domain. Now you can change color tables for pretty much anything. You change it for the DBZ. So if we just hide these, which is a very neat feature, if you click on it, you'll be able to hide it. You'll be able to go down a layer. If you want to hide the vectors, boom, you can hide it. It's very simple. If you want to change DBZ, pseudo color, color table. If I really want it to be hot, sure. Oh wait, that's the same one. Whoops. Hot to saturated. See, it's really kind of weird, but if you really want to choose a new base velocity, hey there, or base reflectivity, there you go. Another one of the things that you can make is vorticity at the surface. So if we go to pseudo color and this one that's called SVS2, this will follow along the ground of where the maximum vorticity is at the surface. So we click surface vorticity and you just draw it. So here it's very, very, very low. It's like 0.03. Actually, let's set it a little higher values. Let's do that. So we can set the maximum value to 2. Yeah. So now boom, it pretty much disappears because there's absolutely no velocity that's really there at all. So it'll go from the max to the minimum. As you see, the minimum is very good. They're very small. The maximum's pretty high. Let's refresh. Let's see if there's any vorticity that shows up in the fields. Or whoop, I just went backwards. Oh, the storm's hooking very, very nicely right now. Let's see. Let's see what it looks like at the surface. Let's open vinterp. The rotation's kind of weak. You can see it's in there. The vectors show it. They tend to show it a little bit better than most other things. This is also where if you have really small time steps, you'll be able to see evolutions a lot better. So I always like setting mine at 150, but in this instance I didn't. But here you can see where, you know, RFD is wrapping around, the inflow's coming in, and boom, you got it right in the center there. So you turn all these variables on, you can see there's not really any rotation showing up with the surface vorticity, but that's okay. Sometimes storms won't generate proper hook echoes. Sometimes you get the best sounding in the world and it just doesn't work out. It's fine. Now, one of the other cool things you can do is you can model this in 3D. So we're just going to hide all these because it'll show up in the model. We'll just hide that. We'll be able to generate that. So what we're going to do is we're going to go add volume. Cloud doesn't work right now, I believe. Yeah, because the variables are invalid right now. So we'll go to volume. We're just gonna simulate in reflectivity. Now this isn't the best thing to do, but it'll work. It'll show us it in 3D. So here's our storm in 3D. The space is kind of messed up because you need to edit the sliders. So if we go over to transfer function, see how a lot of this is right here? If we just edit that out by dragging and sliding to the bottom, boom, it all goes away. It clears it out. So now we have a really robust supercell that you can see in 3D. You can move it around, you can pan it, do whatever. You can put it in different spots. Ooh, look at that hook. That looks crazy cool. You can expand it. You can step forward and backwards in the model just from right here. That's fine. We're going to go to the end of the model here. You can change the center and where you have your points on here. So let's say I wanted a model to be really close to what's going on right here. So I'm going to zoom in a little bit. I'm going to try to get it centered. And I'm going to right click and I'm going to choose center. And I'm just going to click right here. And boom, you can do the area in the immediate vicinity of it. So you can see where the RFD is wrapping around. You got your inflow going around. If you look from under, you'll be able to see where the really intense rotation is right now. So there's the basics of what you can really do. There's a lot more advanced stuff. I don't know if I'll be able to go into it, but if there's any updates, I'll probably post them. If there's any new things that come on, I'll try to update the description as much as I can. But yeah, if you really want to model thunderstorms, hey, this is the way to go. It's very fun. You can get some cool stuff, get some nice swirls, and yeah, that's about it.